Hello, good day, viewers. Still on absolute value inequalities. Today we have another double absolute value inequality, which is the absolute value of 2x plus 5 less than or equal to 3 multiplied by the absolute value of x minus 2. Whenever you have this situation whereby the left and the right hand side are all positive, you're always free to square both sides. So you should remember that this can be expressed as what? The square root of 2x plus 5 whole squared, right? And this is less than or equal to 3 multiplied by the square root of x minus 2 whole squared as well. All right, so if you square both sides, you square the left hand side, you square the other side, right? From the left hand side, this will cancel this, leaving only 2x plus 5 whole squared less than or equal to, from here this power of 2 will affect this one, so we have 3 squared, right? So we have 3 squared, and it is going to affect this one, will cancel this, so we have multiplied by x minus 2 whole squared. And according to one of the laws of indices, since they have the same power of 2, you can multiply the bases and assign them a single exponent. So this is 2x plus 5 whole squared less than or equal to 3 multiplied by x is 3x, 3 multiplied by negative 2 is negative 6. The whole of this whole squared. So we have just multiplied the bases and assigned them a single exponent, which is 2. From here, we can take this one to the left hand side. It becomes negative. So we have 2x plus 5 raised to the power of 2 minus 3x minus 6 also raised to the power of 2. This is less than or equal to 0. This is nothing but difference of two squares. Remember, if you have a squared minus b squared, this is equal to a plus b multiplied by a minus b. We are going to apply the same principle, for which this is our a and this is our b. So let's start with addition, a plus b. If you take this, you add it to this one, we have 2x, 3x, making 5x's. So this is 5x. Then 5 plus negative 6, that will give us negative 1. Then multiplied by, this time around we're going to subtract 2x minus 3x, that will give us negative x. 5 minus 6, that will be plus 11, and this is less than or equal to 0. Let's find the zeros of these functions. If you set this one to be equal to 0, it implies x is equal to 1 over 5, right? And if you set the other one to be equal to 0, it implies x equal to 11. So these are the zeros of this. But remember, we are looking for the values less than or equal to 0. So let us graph this one. Suppose we have y-axis and x-axis like this. We have values 1 over 5 and 11. They are all positive, so they are to the right hand side, 1 over 5, and we equally have 11. Look at the leading coefficient. If you take this one, you multiply by this, that will give us negative 5x squared. So the leading coefficient is negative, therefore we should expect an up and down parabola. So this is how an up and down parabola looks like. Something like this. So we are looking for the values less than or equal to 0. So below the x-axis, right? So below the x-axis, we are talking about these portions. These portions. So it is what? X belongs to the values from negative infinity down to 1 over 5, inclusive, union from 11 way down to positive infinity. This is said to be the solution to this problem. If you like, you can use intervals to determine whether the solutions are the same. And to find the intervals, you have to use this original equation, inequality, sorry. The zeros of these two will be x equals negative 5 over 2, and this will be x equal to 2. So you form three intervals. That is from negative infinity way down to negative 5 over 2. Then you have from negative 5 over 2 way down to 2. And lastly, you have from 2 to positive infinity. Then you test for the values of x within these intervals and confirm the sign of the inequality, whether it is positive or negative. Then you solve. In the end, you take the intersection and union in order to find the solution. But this is actually the solution you have to obtain. Thank you for watching. Do share to your learning colleagues. And don't forget to subscribe to my YouTube channel for more exciting videos. Bye-bye.